Hi, so this is the last page of our review. This is page 4, and we've got 6 solving problems. So there is this mention of extraneous solutions. So again, remember, an extraneous solution just means you might do the work and get a solution, but if you plug it back into the original problem, it actually wouldn't allow the left side to equal the right side. So we'll be looking for that as well. So for the most part, our goal will be to isolate x or isolate the radical. So it really just depends on how many x's appear in the problem. So in the problems that I'm putting with a blue wall, there is just one type of x. You can't see all these. And my goal is just to get x by itself. So pretty much for these 4 problems, I will work backwards in the order of operations. So for instance, in this problem, to solve for x, there is addition subtraction, but it's in the parentheses, so I won't do that yet. Instead, I'll move the 2. And this is 2 times x minus 1 cubed. So I'll divide by 2, since they multiplied, and that gives me 8. So this step didn't happen. I just did this step. And now to get rid of the cubed exponent, I will use a cube root. So when I cube root this side, I'm left with x minus 1. And when I cube root this side, the cube root of 8 is 2. And now to solve for x, I do the stuff that's in the parentheses, just add the 1 over, and you get 3. So would this be an extraneous solution? You really don't have to check with something that's cubed. But if you just want to keep this option up, I would just go to the left side. I would type it in exactly as I see it and see, do I get 16? And you do, so this is a solution. So I'm going to circle it. So let's do another one. I'm going to solve for x. Here is my checklist. X minus 2 to the 3/2 power. There was none of this. There was none of this. There is addition, subtraction, but that's in the parentheses. So I'm going to have to get rid of the exponent. And the way you get rid of the 3/2 power is to use its reciprocal as the exponent. So what's going to happen is I'm going to take this side to the, it's really small, 2/3 power, and that means I'm going to take 64 to the 2/3 power. I'm not multiplying 64 by 2/3, but 2/3 is an exponent. So what happens is these exponents on the left side become 6 over 6, which is 1. And anything to the first power, they don't write the first power, so this just becomes x minus 2. So when I take 64 to the 2/3 power, let me write it here. Again, I could just type that into my calculator, but it just means this. This is good practice to know. I would take the cubed root of 64 first, which is 4, and then I would square that 4, and this side becomes 16. And then I still have the x minus 2. If I add 2 over, then I'm assuming my answer is 18. So if I just went to the left side, and I put exactly as I see it, 18 minus 2 exponent. I am using the older operating system, so I have to type all of this in parentheses so it knows that 3/2 is the whole exponent. Do I get 64? And I do. So I'm going to circle this. This counts as an answer. Let's just keep going. So in this case, since I have a radical, my goal is to isolate the radical when I have more than one x. And now what I'll need to do is to get into anything that's in the radical. After I isolate the radical, then I want to get rid of the radical. So first isolate it, then get rid of it. So like in comparison for f, I would have to isolate this cube root first by moving the 4 and the 2 over, but this one is isolated. So to get rid of a square root, I square both sides. The square totally cancels out that square root, so you're left with x plus 1, and 4 squared is 16, and now I'll just subtract 1, and I get 15. Is this really a solution? Again, just go to your square root button, type in 16 plus 1, and do I get 4? Ooh, no, sorry, I didn't type that in correctly. 15 plus 1. And I do. So this is an answer. I'm going to go ahead and circle it. So again, the big difference between D and F is this was isolated, and here I do have to isolate. So I'm going to add the 2, and that gives me 12. and then I'm going to divide by the 4, which gives me 3. So the only thing that's left on this side is the cubed root of x plus 1. Now that it's isolated, I want to be able to work with this x plus 1, and I won't be able to do that. And again, I technically just did this too. And that's what I did here. To get rid of the cube root, I will cube both sides. So when I cube this side, this cube cancels out the cube root. I'm left with x plus 1. And then I'll cube this side. So 3 times 3 times 3, which is 27. And then if I subtract 1, I get 26. So again, usually a cube root, you don't have to check for extraneous solutions. But if I just put this back in, 4, if I press the math button, that's how I will access my cube root button. And I'll put 26 in. Make sure that you now are out of the cube root, and then I'll do minus 2, and I should get 10. So this is an answer. All right, the other problems, if you look at them, they have more than one x. So my goal is to basically isolate, in this case, a radical from a radical, and technically a 1/2 is like a square root. I just want to isolate it so it's just the exponent. So let's start with the easier problem. So here where I said isolate the radical, if there's more than one radical, you actually want to isolate them from each other. So you got to make sure one's on one side of the equal sign, one's on the other side of the equal sign. And then what I'll do to get to the stuff inside the radical is I'll undo that radical, which is just simply squaring both sides, which drops the square roots, and then I can solve for x. So in this case, maybe I'll bring this x to join the 2x, so I get an x, and then I'd add a 5 to the 7 and get 12. So as far as checking here, this would definitely take a little bit more work. I'm going to do this one by hand. So on the left side, I would put 12 in, so 2 times 12, and then subtract 5. And then on the right side, I would put 12 in. I'm going to do the right side because it's less math. I'll get 19. Now, granted, I don't know the square root of 19, but that's all my goal is over here, is do I get the square root of 19? And I do, because 24 comes from the multiplying. And then when I subtract this 5, I get a square root of 19. So the left side does equal the right side. It's just not a nice number. So in this case, what I want to do is technically, this is another way you could look at it if you really want. A 1/2 is a square root. I don't want you to look at it like that. Your goal is this is isolated, and you want to get to the stuff inside of there. So to undo a 1/2 power, you use that exponent's reciprocal. So that's just a 2 over 1, which is just squaring it. So, or square this side and square this side. And when you're done, either way, the left side is now just 9x minus 20, and the right side is x squared. And now we're going back to chapter 2. We have more than one type of x, so I do need to get x, everything on one side, because I'll have to factor. So I'm going to subtract the 9x to over here. And some of you might think, well, isn't it easier just to bring the x squared over here? That is true, but we've never factored with the negative x squared. So it's easier later to subtract the 9x and to add the 20. So subtract the 9x and add the 20. It is in standard form, ax squared bx plus c. And then I can factor. So factors of 20 that get me to this negative 9 would be negative 4x and negative 5x. And then I can go straight to my parentheses and ask, okay, x times x, those are the first neighbors that would meet to make x squared. And now I'm going to draw my loops with the hope of getting these. So can I take x times something to get to here? And I can. That's minus 4. And then can I take x times something to get to this? That would be a negative 5. And then when solving, it's just what makes those 0, and I get 5 and 4. So the goal now is, are either of these extraneous? So if I put 5 on the left side and 5 on the right side, if I do this, will I get 5? And if I put 4 in, will I get 4 from the right side as well? So the main thing is just put 5 in, you get 5, put 4 in, you get 4. So parentheses, 9 times 5 minus 20, exponent of 1/2. And I'm looking, because I put the 5 in, do I get 5? And I do, so 5 works. And then if I put 4 in, do I get 4? And I do. So both answers work. There's nothing extraneous. And none of these have an extraneous solution. So I will say, as far as the chapter test goes, you don't have to worry about an extraneous solution. It's just something that's nice to know. And that's it. That is your review.